So, what if I told you that the lives of over 1 billion people are pretty much defined by a single massive seasonal flip of the wind? Yeah. Today, we're going to unpack the Indian climate. It's this powerful system of really scorching heat, incredible rain, and the towering mountains that shape it all. Let's dive in. Okay, so here's our game plan. First, we're going to tackle the big puzzle of India's climate. Then we'll walk through the year through its 4 very distinct seasons. We'll follow the great monsoon as it arrives and then as it leaves, check out the power of those coastal cyclones, and finally, see how this all comes together to create a land of just unbelievable contrasts. Okay, so that's really the heart of it for me. I mean, you see these brutal summers that just give way to months of insane flooding rain, and then boom, it's cool and dry for winter. How can one place have such huge, predictable swings? It really feels like there's some kind of massive engine at work. But what's actually driving it? And you know what? That's exactly what it is, an engine. The whole thing really boils down to this one idea, a tropical monsoon climate. And the key isn't just the rain, it's the reversal. The word monsoon actually comes from the Arabic word for season, because it's all about this massive seasonal flip in wind direction. These winds are basically the architects of India's climate. They call all the shots on rainfall. Got it. So this massive wind reversal is the what. But naturally, that leads to the next big question. Why does it happen? What are the basic forces that are actually steering this continent-sized weather machine? It really comes down to these 5 main controls. First up, latitude. India sits right in the tropics, which means it gets absolutely blasted by the sun. Then you've got altitude. Its huge mountains create their own cold climates. Distance from the sea gives the coasts a nice, moderate climate, while the inland areas get wild extremes. Relief, the shape of the land, acts like a massive wall. And all of these things work together to direct the star of our show, the monsoon winds. And of all those factors, this one is the absolute game changer. The Himalayas aren't just mountains. They are a climatic fortress. In the winter, they literally block these bone-chilling winds from Central Asia from ever getting to the subcontinent. Seriously, without that shield, northern India would be a totally different, much colder place. So with all that going on, how does the year officially break down? Like, what are the official seasons?
Right, it plays out in 4 pretty distinct acts. It kicks off with the cool, clear skies of winter. Then, from about March to May, things really heat up. The pressure builds during the intense summer, and that sets the stage for the main event, the arrival of the southwest monsoon. And finally, as the whole system starts to wind down, you get the retreating monsoon, which is kind of like a final encore of rain for certain parts of the country.
Okay, but hold on a minute. If winter is the dry season, then why do parts of northern India get a good amount of rain and snow during that time? It doesn't add up because that moisture definitely isn't coming from the summer monsoon. So, what's the deal? That is a very sharp observation. And the answer isn't actually in India at all. It starts thousands of kilometers away, over the Mediterranean Sea. They're called Western disturbances. These are powerful storm systems that travel all the way across the Middle East, scooping up moisture as they go before they finally hit northern India and deliver that really crucial winter rain. And their impact is huge. For farmers in the northern plains, that winter rain is an absolute lifeline. It lets them grow essential crops like wheat when it would otherwise be totally dry. And up in the mountains, these disturbances dump tons of snow, creating this frozen reservoir that feeds India's great rivers long after the storms are gone. So after those western disturbances are done, the whole system pivots. The sun gets higher, the temperature starts to creep up, and then it just soars. What exactly is flipping the switch and creating that legendary scorching heat of an Indian summer? It all kicks off with the sun. As it shifts north, it just beats down on the Indian landmass, relentlessly baking it. This creates a huge area of low atmospheric pressure that acts kind of like a giant thermal vacuum. And this vacuum doesn't just sit there. It starts pulling in superheated air, creating those infamous drying Lu winds that just scorch the northern plains. And I'm guessing that low pressure system is the key to the monsoon itself, right? Exactly. It's a pretty simple 3-step dance. Step 1. Just like we see here, the land gets super hot, creating low pressure. Step 2, meanwhile, the ocean stays cooler, so it keeps a high-pressure area. And step 3, this is just basic physics. Air always flows from high pressure to low, so that flow pulls all that moist air from the ocean right over the land. That is the monsoon engine. Yeah, the arrival is a huge national event. Around the first week of June, the monsoon makes this dramatic entrance on the Kerala coast. But it doesn't just march forward in one big wall of water. It splits into two arms right away. You've got the Arabian Sea branch, which pushes up the west coast, and the Bay of Bengal branch, which curls around to soak the east. That makes total sense. But if the monsoon covers pretty much the whole country, why isn't the rain spread out evenly? I mean, some places get completely swamped, while others, sometimes just on the other side of a mountain range, stay almost bone dry. What's causing such a massive difference? The answer is something called orographic rainfall, and it's all about mountains. On the windward side, that's the side facing the wind, all that moist air gets forced to climb. As it goes up, it cools down and just has to dump its moisture as torrential rain. By the time that air makes it over to the other side, the leeward side, it's all dried out. It sinks, warms up, and creates what we call a rain shadow, an area that's starved for rain. This is exactly what happens along India's Western Ghats. Okay, so by late September, that monsoon engine is starting to run out of steam. But just when you think things are drying out, the script flips. The southeastern coast, especially places like Tamil Nadu, suddenly starts getting its heaviest rain of the whole year. What's happening? Is this like a second monsoon or something? It's not a second monsoon, but it is the second half of that great reversal we talked about, the retreating monsoon. See, the sun moves south, the land finally cools down, and that huge low-pressure system over northern India just collapses. The entire pressure system flips. Now, dry winds blow from the land out to sea. But, and this is the key, as those winds cross the warm Bay of Bengal, they soak up a ton of moisture and deliver it straight to the southeastern coast. So, the monsoon isn't the only big weather event, right? Those same warm oceans that fuel the monsoon must also be what breeds cyclones. But it really seems like the East Coast gets hit way more often. Is that just what I'm noticing, or is there something real to that? Oh, it's absolutely true. While the Arabian Sea does get cyclones, the Bay of Bengal is a much more dangerous breeding ground. Its surface waters are warmer, and the semi-enclosed shape of the bay creates the perfect conditions for these storms to form, get stronger, and then slam into the eastern coast with a lot more frequency and power. So when you put it all together, the monsoon, the mountains, the oceans, you don't get one single climate. What you get is a country of just stunning contrasts. Trying to find an average weather for India? It's pretty much impossible. And nothing shows this better than just looking at the raw numbers. In the northeast, you have the town of Masiram. It gets over 11,000 millimeters of rain a year. That's over 36 feet of rain. It is one of the wettest places on the entire planet. At the same time, out west in the Thar Desert, they get less than 300 millimeters. You've got the difference between a rainforest and a desert, all inside one country and all driven by the very same climate system. So when it comes down to it, it's not just one thing. It's a completely integrated system. You've got the monsoon winds as the engine, the Himalayas acting as the steering wheel, and the oceans providing the fuel. And they all interact with the local geography to create this incredible diversity.
That's the perfect way to put it. Every single piece is essential to the whole.
We've seen how all these immense forces are locked together in this intricate, really delicate dance. It's a balance that's been fine-tuned over millennia. Which, of course, leaves us with one final crucial question. In a world that's changing fast, what happens when you start to alter one of those pieces? What happens to the balance then?